I'm the first to like call this mistake out. Who knows? This problem is going to be floating around in the MIT rule book. I mean, because MIT says one way, and it's like, no, look at that. All right, go. This is the prerequisite for this problem. You're given this. You're like, what the hell? But you're integrating between negative 1/2 and 1/2. So just throw in 0. If you throw in 0, yeah, it should be 1 plus square. You know what I mean? You get 1 and 1 there. And then, yeah, square root of 1 is 1. And then 1 plus 1 is 2. And you get square root of 2. You can do that in 10 seconds. But you should also be able to do... You throw in 1/2, and you should be able to do that in 10 seconds. Why? Because if you throw in 1/2 here, you know what I mean? This is like 0.25, but then you're adding 1 plus 0.25. So don't even do that. What I did right here is just say, hey, it's going to be bigger than 1. So I just write 1.1. This is an identifier. This is not the right answer, but it's saying, hey, it's greater than 1, and I know that. And guess what this is? Well, this is greater than 1. So you have now you're just interested in how the hell square roots work. You know what I mean? But if you have square root of 1.1, well, guess what? That's going to be this is going to be greater than 1. So I just designated it as 1.1 again. I just wrote the same number in just to designate that it's greater than 1. And now we're going to add these two together. We get 2.2. Now we're doing the square root of 2. If we know the square root 2.2, if we know the square root of 2 is 1.4, well, guess what? We know that the square root of a little bit larger number is going to be a little bit larger. So right there, 1.5. So now you know your 2 points. So now you do your graph from negative, negative 0.5, 0 to 0.05. Okay, and guess what the height is here? The height is here is, well, this is 1, this is 2, so it's like 1.4. You know what I mean? Square root of 2. And what's the height over here? Well, it's 1.5. It's a little bit higher. So you have like a little bit higher over here and a little bit higher over here. So just within a minute, you could be able to be like, well, and I don't know if this is the actual right answer. I mean, this might be screaming high, but at least you know the answer is going to be great. This is 1, just 1. So the area here is equal to 1 times 1.4. Or the area here is equal to 1 times the square root of 2, which is just the square root of 2. That's the area. But guess what? It's going to be higher than that. So at the end of the day, it's going to be greater than 1.4. But you don't know how much, but it can't be that much. I mean, and now you know that it's an x squared problem. You know what I mean? I just didn't know if it like went the other way. It might have gone the other way. It might have gone like whoop-de-doo. Who knows? But that's how you do this problem in under 2 minutes. And that's a video. All right, guess what? We got the answer, and it just looks ridiculous. But guess what? It's totally wrong. That's the funniest thing. Is like at the end of the day, this answer is just plain wrong. This number is 1.16, and I've checked it. This way and that way. So here we go. So this is the equation. We're gonna put this in Excel, and you're gonna be like, whoa, that's how I do the area under a curve. So I basically just plugged in this equation for every little digit between negative 1/2, you know what I mean, and 1/2. And so that's the, and what's our 0? Well, our 0, you know what I mean, is right here. That's square root of 2. But guess what? When we put in 1/2, we get more. We get 1.54. So the area under the curve has got to be a number between 1.54 and the square root of 2, which is 1.41. It's hilarious. So we take all the little segments. These little segments are just 0.01, but we add them all up. And guess what the sum of all those segments is? You know what I mean? It's the right answer. So there you go. There's the right answer. Let's highlight that stuff. This is an amazing day. The answer is 1.474. You know what I mean? Or 1.47. Good enough. Their answer is 1.16. So at the end of the day, that's just hilarious. Like after all this gobbledygook, you know what I mean? And props on you if you can do these integrals and know what the hell's going on. But I just showed you there's an easier way. And I made huge amounts of mistakes. So let's go through it one more time. Okay, just to show you that this number that they said was the answer was 1.6. And I went through it line by line and just made sure. Okay, we're gonna put this aside. But we're gonna do this like we had 4 minutes again. If this is our equation, yeah, you throw in 0. And that's the easiest thing. You get the square root of 2. And then the next most logical thing, so that's this. So, and I didn't know. And then I was like, well, this is an x squared. Look at all those x squareds. You know what I mean? This was an x squared problem. And I was just like, well, it might be that. But then it's a square root problem. And I just didn't know much about square roots. So I just didn't know which one it was. But I was going to throw in. But then I learned about square roots. So we're going to go through that. Because check this out. If we throw in a half, you know what I mean? We're gonna go through that. So we did. So x squared becomes 0.25. You know what I mean? X to the 4th. Well, I totally munched that. I did that wrong. So that's just 0.25 times 0.25, which is 25 times 25. So here's what I do. I do 2. Well, what's 10 times 25? That's 250. 250. What's 5? Well, this is just half of 250. So I did 100 and then 25. So that's how I got this. That's kind of how I do this real fast. I'm not using a calculator. They're not using a calculator. So, but anyway, that one I messed up, but I finally got that one right. And so anyway, but at the end of the day, you add this up, you get 1.31. So I was a little off there. But then I still don't know what the hell a square root is. You know what I mean? Okay, a square root is something times something equals this. So I just threw in a big number. I was like, well, maybe it's bigger than that. I have no idea how square roots work. So I typed in 1.8. So that's 18 times 18, and we got 10 times 18 is 180. And then you got, so what did I do? 180. And then 5 times 18 is 90. Okay, just half that. But I still got 3. But I got 3 left. So that's 3 times 10 is 30, plus 3 times 8, 24. So yeah, so we get... And then move the decimal place twice. We get 3.24. Is that our answer? No. I'm going the wrong direction. So too high, too high. So then I would guess something lower than this. And I would just say 1.1. Do the same thing. 1 times 10 times this. So this number becomes 110. That number becomes 11. And you get, and then move the decimal place. So you get 1.21. Well, that's too low. That's too low. So then, I even did 12. And then, well, that's too high. That's interesting because I thought I was going... Oh, no, yeah, this was too high, too high. So instead of 12, I used 1.15. 1.15. And then I got this number that's pretty darn close. And then I didn't even know if I was going too... I was like, oh, this is too low. I need to go the other direction. But anyway, so just very quickly, I got that... What did I choose? I chose that this was 1.14. So that's what I was going to choose for that, and that's what I chose. So now we add these two up, we got 2.39. Square root of 2. What the hell is square root of 2.39? No one knows. But we know that 2 times 2, you know what I mean? I think I wrote that somewhere. I was like, well, what's 2 times 2? Well, that's 2. So then I was like, well, it's got to be bigger than 2. No, what the hell did I do here? Oh, no. See, I'm losing my mind. So if this was 2, I know that 1.414, which is the square root of 2, times the square root of 2. I know the square root of 2. That's the only one I know, is 2. But this is too low. So I need to go up from this. So then I guessed 1.6 times 1.6. I do that same thing. 16 times 16. That's 160. Times 60 times 36. 256. Move the decimal place, we get 2.56. Ooh, that's pretty close. That's a little high. So then I went 15 times, how about just 1.5 times 1.5? Or is the answer 1.5? And pretty close. So then I just guessed in the middle, 1.54. And I just guessed, I don't know, psychologically I might have already known that the answer was 1.548, but really not really. So then I know what the answer is at half. But that's the crazy, I was losing my mind. Because that's where I drew this graph, and I was just like, well, I know that number, and I just didn't know if it was lower. If it was lower, then yes, the area is less. But check this out. Even if you just know this one, and you don't know a darn thing, like the area right here is already higher. The area of this is 1 times 1. The area is 1.414, which is already higher than this number. And it's an x squared. The number's got to be higher than that just by logic. I mean, that's the craziest thing. At the end of the day, you can do a huge, you know what I mean, fumbo jumbo. And it's cool. If you know how to do that, great. But at the end of the day, if you don't know how to do just the simple guesstimate of the area under a curve, and that's why I'm the first to like call this mistake out. Who knows? This problem is going to be floating around in the MIT rule book, you know what I mean, for this is the answer. And I could be just dead wrong. And you know, but I'll take this video down or just make another one. But like, holy Toledo. I was just like, I'm even second guessing myself. I mean, because MIT says one way, and it's like, no, look at that. I mean, I was just so confused. But now, even if you just take so what did I do? I did something cool. Right here. So I just do rectangles. So this is your square, 1 times 1.414, not to scale. But then this is your other rectangle. Well, this is just 1.54 minus 1.4. And then so you get that number times, and it's just a half. Look at that. This distance is only 0.5. So 0.5 times the difference there, and we get 0.065. So here's the answer. So in 4 minutes, yes, I could have probably got here pretty fast. And 1.41 plus 0.065, well, I get this. You know what I mean? At the end of the day, that was going to be my answer if I did things absolutely correct. But the wildest thing is I made so many weird, like, chokes. I made so many weird mistakes. I thought this was a lower number, and I thought the answer over here was lower. So I just made mistakes, and just the fact that I came up with the answer that was super similar. I said the answer was between 1.1 and 1.2, and the answer they gave was 1.16. So I just assumed I was on the right track. But then I double-checked myself, and I was just like, holy Toledo, this is the wrong answer down here. And then I multiplied these two together. I multiplied that times that. That was totally wrong. You got to add them together. You know what I mean? So I thought this number was actually really close to 1. I was like, oh, it's just 1, it's just 1. And so, you know what I mean? I was just like, well, it's not 1.4, it's 1, it's lower. I thought this area was lower. But if I didn't make a mistake, I wouldn't have caught their mistake. So at the end of the day, I hope you're still watching this. And, you know what I mean? Just guess. Just guess engineering. You know what I mean? The first thing, just throw some duct tape on it. See if you know anything. See if you can stop a leak. But yeah, that's how to do math, and that's how to do life. And guess what? That's a video. Alright, what we got here is the MIT integration bee. Now this is not the problem I'm solving. It's the next one. Problem number 3. I got 4 minutes, and I've never seen it.
Alright.
And guess what?
Are both competitors ready?
Here we go.
3,
2,
2,
1,
1.
integrate.
Integrate.
Go. Okay, so we got, let's just say we're integrating from 0 to 0.5. We just want a representative. We want to know what x is 0. So okay, so this is 0 plus 1 plus square root of 0 plus 0 plus 1. That's 1. So you have 2. So you have 2. And then square root of 2. Okay, so we got square root of 2. Now we don't know anything about anything, but we know we're doing it with 1. So it's the same thing. It's the integration of a unit. So we know our triangle, and then we found our halfway point. So this is 0, negative 1/2 to 1/2, and we got square root of 2, which is, isn't that like 1.4? I don't know. So it's like 1.4. 1.4. And let's just say, so you're here, and then you go up. Well, we can just balance this out. That's the halfway point. So my answer is 1.4. I get there. I get there in just like 2 seconds. So I think the answer is just square root of 2. Square root of 2. You know, just something super complex, and you're like, what the hell is the answer? But does that make sense? Now this is an x squared problem. So we know, an x squared problem is like this. The square root of x. Do we know anything about the square root of x? Let's actually do that. So, and then we're going to go from 0 to 1. The square root of 1 is 1. The square root of a small number, like 0.1, is, I don't know. I don't know. So 1 squared is equal to 1 times 1. And then so 0.1 squared is equal to 0.1 times 0.1, which is 0.01. Oh, so the square root of 0.0. So it's what two numbers multiplied together equal this number? Well, 0.1 times 0.1. Well, what two numbers squared? Well, 1 times 0.1, but you can't do that. So then this is going to get lower. This is going to get higher. So yeah, you're going to have like 0.5 times 0.5, but that's 0.25. That's too much. So then you go 0.3 times 0.3, and what do you get? Well, you get 0.09. Oh yeah. So the square root of that is 0.3. Square root of 0.1 is 0.3. Yeah, so you get bigger numbers. Okay, and what's the first number that we got? We got square root of 2. So do we think we're going to get a bigger number? If that's a 0 and we got square root of 2 and we go up, do you think we're going to get a bigger number? Because yeah, you do have this x squared, so it is kind of like maybe it's subdued. But let's just throw in a half. Okay, so we're going to go 0.5. That's 0.25. 0.25 plus 1 plus square root. So we got 0.25. 0.25 times 0.25. Well, that's 25 times 25, which is 250 plus 250 plus 100 plus 25. So we got 75 and 5. We got 575 and then 4. So 0.0575. 0.0575 plus 0.25 plus 1. So we got 1.23075. But then we're taking the square root of that, and then we got 1.125. But we're taking the square root of that. So we know that this is just 1.1, and then times, it's like 1.2, square root of 1.2. Yeah, square root of, like it's almost like 1. So it's 1. So the area, 1.4 to 1. So I'd say it's like 1.1. The area is 1.2. I'd say the area is less than 1.4. That's my final answer. And they're checking their answers. But yeah, because the area is 1 down there, 1 down there. Or it's smaller.
We'll double check Maxim's answer.
This is your highest point. Could be totally wrong, but I just need to see what the answer was.